Hi friends, today we will solve few problems. There is asked in SSC JE Electrical in the year of 2016. Okay, now we will solve the first problem. A current of 5 amps flows through a conductor against a potential difference of 200 volt. The power dissipated will be dash. Okay, this is the question. And once again read the question. A current of 5 amps, that is current of 5 amps flows through a conductor against a potential difference of 200 volt. That is V is equal to 200 volt. The power dissipated will be dash. Okay, that is we are asking how much power will be dissipated by the conductor. Okay, this is the question. Since it is a direct question, because we are having the formula for P is equal to VI. Okay, if we substitute the value for the VI, this 200 into 5, we got 1000 watts. Okay, this is the answer. So the answer is option A, option 1, 1000 watts. Okay, now we solve the second problem. Energy consumed by a heater of rating 1000 watts by operating it for a period of 2 hours will be dash. Okay, see there is having one heater, it is consuming 1000 watts per 1 hour, that is 1000 watts for 1 hour. So if it is operating it for a period of 2 hours, how much will be power consumed? Okay, this is the question. If the heater is, see, for the 1 hour it is consuming 1000 watts, for 2 hours what is the power consumption? That we should get the answer. Okay, so for 1 hour it consuming 1000 watts, so for 2 hours just we need to multiply it by 2. 1000 into 2 hours, so the answer is 2000 watts or 2 kilowatts or units. So the answer is 2. Since it is a direct question, see for 1 hour, see a heater of rating 1000 watts is nothing but for 1 hour it will consume 1000 watts. This is the meaning. So for 1 hour it consumes 1000 watts. So for 2 hours how much energy will be consumed by the heater? That is the question. So for 2 hours it will consume 2 kilowatts. Okay, the answer is option 2. Okay, we will solve the third problem. A resistance R1, R2 are connected in parallel. The ratio of values of resistances R1 is to R2 is 4 is to 1. The current in R1 is to R2 will be equal to dash. Okay, this is the question. Okay, for this problem we don't need any formula, just we need to apply the concept here. See, consider it is a conductor, the current I flow through it, and it is having a resistance of R ohm. So in the conductor where the resistance is high, the current flow will be low. Okay, this is the concept. Here just we need to apply this simple concept here, that is R1 is to R2 is equal to 4 is to 1. Okay, see for the in the R1 conductor we are having the resistance of 4 and the R2 the resistance of 1, that is, so according to the concept where the resistance is high the current flow will be low. So here the resistance is high, so current flow will be low, there is 1, and here the resistance is low, so the current flow will be high, that is 4. So the answer is 1 is to 4. Just we need to apply the simple concept is when the resistance is high the current flow will be low. So finally we got the answer 1 is to 4. So the option is 2, 1 is to 4. Okay, now we will solve the next problem. The resistance of a strip of copper of rectangular cross section is 2 ohm. A metal of resistivity twice that of copper is coated on its upper surface of the thickness equal to the roll of copper strip. the resistance of the composite strip will be dash. Okay, this is the question. Yeah, just we need to initially understand the question first. See, there is a copper. Consider this is a copper metal. The resistance of strip of copper of rectangle cross section is 2 ohm. See, it is a copper. Its resistance is 2 ohm. Then a metal of resistivity twice that of copper. So consider this is one metal. A metal of resistivity twice that of copper. That is, the resistance of copper is 2 ohm. So the twice that of copper is 4 ohm. This metal having a resistance of 4 ohm is coated on its upper surface of a thickness equal to the copper. That is, this metal is coated upon the copper. So this is the copper. Upon this copper, a metal is coated. So here initially the resistance of copper is 2 ohm. Now the resistance of metal surface is 4 ohm. Okay, equal to the copper strip. Okay, both the metal and the copper are in same size. So now this metal is coated upon this copper. So then finally we got this composite material. Composite is nothing but the combination of two or more material. So now we need to find the resistance of the composite strip. So we need to find the total resistance of this strip. So consider this is now it is like initially there is a metal and it is coated upon the copper of 2 ohm and it is 4 ohm. This is the metal and this is the copper. So it is like looking like a parallel combination of two resistance. Okay, we know that the parallel combination of two resistances R1 cross R2 by R1 plus R2. So if we R1 is nothing but 4 into R2 is nothing but 2 by 4 plus 2 is equal to 8 by 6. If we solve this, the answer will be 4 by 3. This is the answer. So the answer is option 2, 4 by 3 ohm. Okay. Okay, this is the answer. So the question, initially we need to understand the question first, then only it is easy to solve the problem. Okay. Okay, now we'll solve this next problem. Two coupled coils of L1 0.8 Henry and L2 0.2 Henry having a coupling coefficient of 0.9. The mutual inductance M is dash. This is the question. See, once again I'm explaining the question. Two coupled coils of L1, that is L1 is equal to 0.8 Henry and L2 is 0.2 Henry. A coupling coefficient K will be 0.9. Now we need to find what is the value of mutual inductance. Okay. Since we are having a direct formula for identify the mutual inductance, that is M is equal to K of square root of L1 cross L2. Just here we need to substitute the values. Okay. The value of K is 0.9, which is nothing but a coupling coefficient. The value of L1 is 0.8 and L2 is 0.2. So if we solve this, 0.9 root of 0.16. So 0.9, the square root of 0.16 will be 0.4. Just if we multiply these both, we got 0.36 as answer. Henry. So the answer is option 3, 0.36 Henry. Okay, this is the answer. Okay. Okay friends, that's all about today's video. In the next video we will solve some more problem which is actually SSC JE electrical. Okay, do support. Thank you.